Dia sharing lagi.
Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all participants. Welcome once again to Day 5 of 23rd of Medical and Health Research Week 2021 by Faculty of Medicine, the National University of Malaysia. Right, so hopefully you guys have been having a very fruitful discussion for the past 4 days. And today we're going to be discussing on something is what I'm going to put as a bit daunting and could be rather nerve-wracking, in which module D on statistic in research. And I think we're going to have someone who is very expert on this area, which is Associate Professor Dr. Azmi, to help us to unpack on these modules. All right, so before we get started, let me just go through the biography of Associate Professor. So Associate Professor Dr. Azmi Muhammad Tamil is a 54-year-old UKM lecturer who will be retired next year. So it will be a big loss to UKM. Hopefully, Prof still don't mind to come here and share his experience. So this is going to be his last research week session before retirement. As a student in UKM, he was a nuisance to his JKM lecturers for disputing the statistical formula taught. Later, he ended up dreading the same things happening back to him. Graduated from UKM in 1992, he taught statistics in UKM since 1996, so that's probably about 25 years. So he is the ultimate example of a frog under the coconut shell, but I would rather put it as a love and loyalty towards UKM. I think that's the best way to put it. More well known on the internet as a technology enthusiast rather than just as an epidemiologist or biostatistician. He has many blogs on all his interests such as gadgets, hacks, triathlon, cycling, statistics, and blogs such as drtamil.me, as you can see in the screen. He also has a YouTube channel on statistics and cycling. All right, so do check out the link that have been given to you. This is the statistic, if not mistaken, modules. They're available online. He believes in freely sharing his knowledge. Therefore, videos and notes for all his statistic lectures are available online, just for free. Just Google for his name, Azmi Muhammad Tamil, and you'll be set for analysis. All right, so let's get the ball rolling. Without further ado, let's help me to welcome Associate Professor Dr. Azmi Muhammad Tamil. So over to you, Prof.
Thank you very much, Dr. Hafiz, for the very kind introduction. Before I start, because I just realized that from the first day, there were participants that have problem with the openlearning.com. Just for your information, I have paid 390 ringgit for the openlearning.com account. Hopefully, Heidi will reimburse back my 390 ringgit. I still have yet to get the money. So we noted 122 of you all managed to register, but there's still another 20 of you who have not registered. So I just would like to bring you through the system. So as you can see, the website is openlearning.com. You just go there. The specific URL for the research week is bit.ly/UKM RW2021. Okay, allow me to show you. Okay. We checked last night, there's only 20 of you who have yet to register. So kindly check whether these email addresses are correct. If these email addresses are not correct, please kindly inform the secretariat and they will change the email address inside the system. Then you can enter the system. How to enter the system is very simple. Okay, so first you go to openlearning.com. Just go to openlearning.com. There's a button on the top right side. They call it sign up. You click on the sign up. You fill in your email address, your name, and your preferred password. Just take note, the password should consist of at least 8 characters with a mix of capital letters, small letters, numbers, and symbols. For example, okay, I know I'm blocking the example password. Okay, just make sure that it has a mix of all that thing. Okay. So after you registered, they will send a verification email to your account. So just go and verify your email address. So just go there to your email account, click on that green button there. verify email address. Once you click that one, you automatically will be brought to openlearning.com, and at the openlearning.com, they will say that your account is registered and you are automatically enrolled into this research week. Okay, so everything is there. Everything is there. I know 122 of you have already registered. Some of you already done 30% of the content. What is there? We have all the notes. We have all the video, the Zoom video, and we already set each video individually. So when you click it, it will go straight at the point where you want to start for the session. So please kindly register and make use of what we have prepared for you. Okay. I'm going to change slide now for the proper lecture for today. So my apologies for that change. Yeah, I'm not sure why I'm still seeing the QR code for the Zoom session. Okay. Okay, let me set. Okay, thank you. Okay. So I'm going to change the slide to my own slide for today. So for today, we are going to talk about sample size. Okay. One thing I realized after 4 days of listening, I've been listening along with you all. There is too much confusing information. Okay. Why I say confusing? On some days, you have the same topic being taught twice. Okay. Thrice, in fact, for the clinical trial. So in each one is saying different things, which is, I'm sure, not very helpful to you all. Okay. So today I'm going to cover another part, which is going to be even worse. We're going to talk about sample size. Okay. So I'm going to share the slide. Okay. Allow me to move the slide a bit to the right side. Okay, because otherwise we will not be taking advantage of the whole thing. Okay, much better. Okay, I know I'm I'm dressed in black. Woo, man in black. So nampak gigi ya. Alright, so allow me to share. Okay, I'm going to share the screen now. Okay, my apologies to the person in charge. Okay. So first, I'm going to click on the share button. Okay. Forgive this old man. I'm the dinosaur here. I'm the oldest among you all. So being a dinosaur, kindly give me some leeway in the use of technology. Okay. So I'm sharing now the screen. So hopefully you're seeing the picture of me on the left side, dressed in dark. It's not my idea to dress in black. I wanted to wear white, but my wife insisted of me wearing this black shirt. So suddenly I go missing inside the green screen. Okay. Okay. So next, I'm going to go through the slide. Okay. 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 Why I have to? Because basically, what is happening right now? I know you cannot see what you're seeing here. I'm looking at 3 screens right now. I'm looking at 3 screens. Okay, okay, there's chat there, chat, link to registration. It's openlearning.com. To register, it is at openlearning.com. I'm going to type it at the chat, openlearning.com. Just register using the email address that you have sent to the secretariat. Okay, oh, sorry, I sent to the wrong one. I sent it to the panelists. Okay, susah jadi orang tua ni kan. Orang tua dia tak pandai teknologi. Saya in fact when I went to T-Life, I wanted to buy using Grab. I had to ask the cashier how to use the Grab account to pay for the T-Life. Embarrassing. All right. Okay, so we're going to talk about sample size. Basically, why we talk about sample size? Because that's the thing that you all are worried about. Personally, before the year 2006, nobody talks about sample size. But Prof. Saizul came back from Australia and he became part of the ethics committee, and he insisted that every study must calculate their sample size. Okay, so let's see why it is so important. So basically, I'm going to give an example here. Okay, here we have a small study, consists of only 8 samples. Okay, one is treated with the usual chemotherapy, the other one is treated with placebo. Although they can see that clearly the treatment has a better effect, 100% were cured. Okay, and those on placebo, 50% end up with relapse, 50% did not end up with relapse. And although there's a difference of 50%, but because of the sample size, which is too small, you can see that clearly that the p-value, the statistical test, shows that there is no significant difference between the two. The p-value is larger than 0.05. Doctor, what is 0.05? Don't worry, I'm going to cover that in the next lecture after the break. Okay, so there's suddenly it shows that the placebo, it could be your whatever lah, could be your ivermectin, could be your I baca whatever, yeah. So it could be. So no difference, no difference. So the placebo is as good as the treatment itself. Okay. If you increase the sample size from 8 to become 16, you can see that the p-value is improving. If you look at the uncorrected chi-square, it is 0.02 already. But as you all know, since sample size is too small, you cannot use chi-square. So you have to use Fisher exact test. You can see the Fisher exact test, the p-value is just above 0.05. The p-value is 0.07. So although there is a difference, the difference is not yet statistically significant. Why? The sample size is not large enough. Okay, so increase it some more, from 16 become 32. Okay, suddenly, finally, when you have a sample size of 32, you can see that the p-value is finally significant. For the, since it is now already 32, there's no expected value of less than 5. Oh, sorry, there's an expected value of less than 5. So you can use Yates correction. So Yates correction here, the p-value is 0.004, or you can follow what the software recommended to use Fisher's exact test. We give you a p-value of 0.002, which is smaller than 0.05. So now finally the null hypothesis is rejected. Yes, the treatment has a significant effect on the outcome. Why? 0% relapse, whereby placebo got 50% relapse, and the straw man is finally knocked down. Okay, so this is an explanation why we have to have adequate sample size. Yeah. But if you last time, way back in 2006, you come to JKM, we just say anything over 100, you're okay. All right. Okay. Let's start the game. Yeah, let's start the game. Okay, I'm not sure whether you can see this or not because my screen is not so good. There's a URL there, bit.ly /design UKM, or you can use your QR code, okay, to open it up. Okay, just go there. Let's see whether you know what is your study design. Let's see whether you know what is your study design. Because you have listened to the talk for the last 4 days. Something must have stuck inside your mind. Hopefully now you know what study design you're using. Okay, I'm going to stop sharing this PowerPoint. Okay, I'm going to change to the website, okay, which is bit.ly design UKM. Okay, so let's see whether it works or not. Okay, I'm going to stop sharing now. Okay, hopefully this old man does not mess this up. Susah jadi orang tua tau, mata dah tak nampak. Okay, jantung pun sudah operate. Okay. I'm looking forward to my retirement. Okay. Okay, so I'm going to open up the bit.ly.design.ukm. Okay, so I'm going to open up that one. Let's see whether, okay. Okay, bit.ly, bit.ly design UKM. So I'm going to share back that screen. Good. Maybe I should share back that screen. Siapa nama ni? Afiq, lupa nama kau spotlight my video so that they can see the QR code. Okay, thank you. Lupa. That shows I'm developing everything. I think I should be taking ginkgo biloba to help with my memory. Okay. So what's happening now? You all are seeing my QR code. So hopefully some of you have figured out how to use the QR code and managed to go to that website. Okay, I'm going to go there, bit.ly/designukm. Okay, let's see. Okay, let's see what's the answers like. Okay, let's see the response. I got 26 responses. Wow, good. Okay, I'm going to share this screen. Hopefully I figured out already how to share this. Okay. As mentioned just now, I got so many screens. So I'm going to try and share that screen of the results. Okay, share. Laboratory experiential that is under clinical trial. Okay. Dia tanya laboratory experiment. Okay. Because okay. So looking at this, 28.2% wants to do clinical trial. No, case cross-section study, 27.5. Next one, the highest one is 19%, green color, diagnostic study. No, this is diagnostic study. It's cohort study. Come on, man. Cohort? Really? Okay. Okay, so okay, let's see in terms of text. What was the best? Okay. 42 responses. So basically, most of you are doing cross-section. Okay, so followed by the one for case control is about 7.1%. For clinical trial is 11.9%. This green color is cohort, which is a bit weird because I don't know what to say. Okay. Okay. Okay, Shin Jianwei, I will solve your problem during the lunch break. If you already registered for the open learning, Shin Jianwei, you just go to the link that I gave earlier. You go to the link bit.ly, bit.ly/UKM, UKM small letter, RW big capital letter, 2021, you will get the notes are all there. Okay. All right. Thank you very much for the participation. So I'm right to think that cross-sectional is going to be the largest group. Cohort, I'm worried a bit because I don't think it should be cohort. Okay. But anyhow, okay. How about the website? Where to get the notes, everything? Okay. You go to bit.ly/UKM small letter RW huruf besar, then 2021. You go there. When you click, okay. Okay, how long is the content is available? Until the 7th of July 2022. What happened after 7th of July 2022? The payment expired. The payment expired. The subscription expired. So after subscription expired, You cannot. I cannot renew. Why? Because by the time I already be retired from UKM, Heidi will not be paying me to or reimburse me, so I better not pay for it lah. So after the 7th of July next year, okay, you can see here everything is being shown to. Okay, so they teach you how to use the system, whatever, but don't worry, because once you are there, you can see on the left side everything is there. For example, my talk today, stats 1, you click on stats 1. Okay. Not only they have a nice picture of me, okay, they have the Dr. Said Alafi's name there, Said Hashim. Sorry, they didn't have a picture of him. That's my picture there. The picture was taken long ago. Okay, so you can see the notes are there. It is downloadable. You can download the notes. The video is on the right side. The video. Right now, this video is from last year. This video is from last year. But as we finish today's session, Afiq will send me the link for the Zoom video. I will edit the video and I will upload it to the website. Okay, Chin Jian Wei, I already explained inside the video just now. You're supposed to register. You go to openlearning.com. Okay, I did the whole video just now. Sorry, a whole PowerPoint presentation on how to register. Go to openlearning.com. Click on the button sign up. Then you register. When you register, then you verify your email. Automatically, you will be entered to the system. Okay, so change your way. Come on lah. If this dinosaur can do it, you all are young people. You all should be teaching me on how to use this. Okay, don't let the old dinosaur teach you how to use open learning. Let alone how to register. Embarrassing, man. Old dinosaur teaching you all. All right, so let's not get bogged down on the part. Okay, so we're going to go now to the next part, which is the lecture. Already shown you how to access the lecture notes. Okay, should not be a problem. Okay, so I'm going to stop sharing now. Okay, I'm going to share back my PowerPoint. Okay, my apologies. So I'm going to share back my PowerPoint. Okay, so first thing first, click butang share. Macam budak sekolah ni, kena belajar balik tekan butang share. Lepas tekan butang share, nampak share screen 3. I got so many share screen here. Oh, this is not the share screen. This is the second one. Correct. That's what happens when you have too many screens to share. Okay. So we already covered that. Okay, thank you very much. So basically you're saying that you're doing cross-section study. Okay. Not many answered prevalence or descriptive study. Okay, basically most of you answered cross-sectional and cohort. Okay, about 7.1% answered for case control. Okay. So I'm going to go next. Sorry, I just remembered. I'm clicking on the wrong page. Okay, sorry. Forgive this old man. Okay, next. Okay, just take note, this is a very short set of slides. There are a larger set number of slides. The larger set of slides is available at drtamil.me. My name is Azmi Muhammad Tamil, anak Tamil tapi orang Melayu. So since my father's name is quite unique, so I registered the domain name drtamil.me. So you can just go to drtamil.me. Okay, what is my name? Azmi Muhammad Tamil. So drtamil.me. So you just go there, and there is a set of all these notes. The set of all these notes, you can go and get it. Okay, you can go and get it. Okay, all right. Okay, thank you, Dr. Hafiz. All right, so we are going to go, just so that is the notes. So if you download my notes from the openlearning.com, you will get all these hyperlink available. When you click, this hyperlink will bring you to the respective notes itself. It is all going back to go to the original file. So you can download each one of these files and peruse them in your own sweet time. Okay. So let's start with the first one. Okay. Just now you mentioned, you saw it's now 28% wanted to do cross-section study. But cross-section study, you got two types. One type is where you just measuring prevalence. The other one is where you're trying to find relationship between the risk factor and the outcome. So you're going to look at the first part, and the first part is looking at the prevalence. Okay. If the objective of your study is to measure the prevalence of the outcome of interest, then you will be conducting a cross-section study, but descriptive only. Descriptive only. You're going to describe. Okay. So you will only take a sample of your population, and the number of samples selected depends on the expected prevalence rate. Okay. So, for example, you want to do a study on obesity. Okay. You want to do a study on obesity, the prevalence rate, based on the National Health Mobility Survey, is 20%. So based on the 20%, you will calculate the sample size required for the sample size. Okay. Okay. So that is how you go about. How to do? Simple. The formula is given there. Okay. Okay. The formula is given there. What is PP for prevalence? What is Z? Z is the for the Z value for normal distribution of 95%, which is 1.96. So 1.96 you square it, become 3.84. So the P is prevalence, 1 minus P is 1 minus prevalence, and D is the level of accuracy. D is the level of accuracy. So usually we set the level of accuracy is either at 3% or 5%. Either 3 or 5. Okay. Ini bukan cerita 3 Abdul, 20%. Tak ada. Kita kena ambil 3 ataupun 5%. 3 or 5%. Okay. But of course, the easiest one is to use the attached Excel file. You click this one, you click on this link, you get my Excel file. So Excel file, you can download it from pumpx.org/sample size. Okay, I know I'm mentioning a lot of URL there. Okay, I'm going to type down there for you all to see. Pumpx. Remember pump? You tapak tangan pumpx.org/sample size. Okay. So you go there, you can download the Excel file. So you go there, you download the Excel file. The Excel file will help you to calculate the sample size. That is how much help we are giving you. We are giving you the Excel file. So how to use the formula just now? Just now we mentioned about 1.96. So 1.96, okay. So the P value for 1.96. Okay, sorry. The Z value for 95% confidence interval is 1.96. Okay, so 1.96. So you, based on that 1.96, you put it into the formula. You have a expected prevalence value of 20% for obesity. Your accuracy you wanted is 5%, so you put into the formula. So the formula looks like what? Formula looks like this. Okay, so you have 20%, you have 5%, you have the sample size required, which is n equals 1.96. Okay, n equals 1.96 times 0.2 in bracket 1 minus 0.2 close bracket. Okay, then divided by 0.05 squared. Why divide by 0.05? That 5% accuracy is that value. So you end up requiring a sample size of 246. But of course, the easiest one is just to download my Excel file. My Excel file will tell you exactly the sample size required. If your prevalence is 20%, the sample size required is 246. Okay, so that is how easy it is. Just download the Excel file from pumpx.org/sample size, and you can get the Excel file. Everything is there. Everything is there. Even my notes, the full notes is also there. Okay, next. Oops. Okay. Okay. Please take note. If your samples, if your prevalence rate is below 5%, you should not be doing a cross-section study. This one is to be covered by Azimatun. This one is to be covered by Zaleha. If you want to do a prevalence study for a rare disease, you are in trouble. Why? Because you end up with a very small sample size which are positive. Therefore, if your supervisor is very stubborn, still insists that you do a cross-section study, then the level of precision should be half of the prevalence. For example, if you're doing a study on HIV among STD patients, the prevalence is only 4%. Therefore, the level of accuracy should be set at 2%. So when you set the level of accuracy at 2%, the sample size will be humongous. It will be at least 360 69, not 59 sample size. Okay, so just take note of that. Okay. Okay. So that is if you're just doing a private study. But my dear, if you're doing your masters, you should not be doing a private study. Okay, because you all are supposed to be master. When we see a master, we bow. Okay, you just do a private study. So what? Even undergrad can do. So it does not matter. So most of you will end up having to find cause and effect. Find whether there's any relationship between the risk factor and the outcome. So although you're just doing a cross-section study, okay, you will be trying to find out the relationship between the risk factor and the outcome. Okay, risk factor present, absent. Outcome present, absent. Risk factor obese or not obese. Outcome diabetes or not diabetic. Okay, so when you have this sort of thing, yes or no scenario, we call that dichotomous. Dichotomous. How to remember? You marry two, you die. Dichotomous. All right. So let's go to the next one. Okay. So it could be any of the design. It could be a cross-sectional study. It could be a cohort study. It could be a case control study. It could be a clinical trial. Okay. The scenario is always the same. Scenario is always the same. You can see here. You start for the cross-section study. You look for the risk factor, and you look how many with the risk factor end up with the disease. How many with those without risk factor end up with the disease. You compare this ratio. The disease among those exposed and the disease among those not exposed. Okay, same thing for cohort. But now cohort, you're looking for it in time. You look for the risk factor at the start of study. You look for the outcome at the end of the study. Okay, then you have the case control. Case control is the other way around. You start with the disease first. This one, Rosalia already covered. You start with the disease first, and you look for the risk factor in the past. You look backwards in time and see whether they have the risk factor in the past. And then for clinical trial, you have the intervention. One group you give the intervention, the other group you give the control or the placebo, and you see whether the patient end up being cured or not. Okay, so that is we call what we call dichotomous risk factor and dichotomous outcome. Okay, for all these things, the method to calculate sample size is similar. Does not matter either you're looking forward at the rate of the disease or looking backward for the rate of exposure. Okay, for this scenario, I'm going to give an example, a simple one. Okay, identify the rate of the disease among those without and among those with and without a risk factor. Okay, why? In this scenario, we're trying to look for overweight have a higher risk of DM. This example. So you look for literature review. You look for literature review. Here, in this case, we give equal ratio. Those who are obese and those who are not obese. Okay, those who are obese at higher risk of getting diabetes mellitus. Those who are not obese, they have normal. Okay. So you look for literature review. What is the proportion of diabetes mellitus among the normal population? You find out it is only 7%. You look for the proportion of DM among those at risk. Okay, you find out it is about 32%. Make sure you quote the reference at the bottom. So here I will have the reference at the bottom. Okay. So this one just to put the whole thing in a schematic view. You can see 32% versus 7%. So based on this data set, you can calculate it manually using one of these formula. There are many formulas. Please take note. There are many formulas. One is Fliss JL. There's Sichelman's formula. There's the Hanneken formula. I use Fliss JL because it is the formula being used inside the software EpiInfo. StatCap, we call it. Why I have the formula here? So that you can print screen and put inside your thesis. Pandai print screen kan? Kat keyboard tu ada butang print screen, PRT, SCR. Press that one. Then you can paste it inside your format in your thesis. Okay. But of course, you don't calculate manually. You use the software. You can calculate manually, but it'll take you about 3 days. I should know. I tried. Okay. What you do? Download the software. Okay. You can see here. I give you software. Just put in the value. Automatically, the software will calculate for you. Okay. It's an Excel file. Excel file boleh tolong kira. So sample size required is 46 each for both groups. You end up with 92. So you end up with 92. Okay, but I'm going to share with you all something better. And what is that better thing? The better thing is the software PS2. When I teach this one PS2 way back in the year 2006 or 2007, I have participants asking whether it is the PS2, the PlayStation. No, it's not the PlayStation. Okay, it is the software, power, and sample size. So I'm going to open up my Google Form balik. Google Form lagi. My browser. I'm going to share that browser. Okay, I'm just going to show you how to look for the file. Apparently, although you all are they call it the millennials, lahir daripada perut mak terus dapat komputer satu, so terus dapat tablet. So by right you're supposed to be very good in using IT. Supposed to be, yeah. But I'm going to show you anyway to avoid questions being asked. Okay, I'm going to share that Google form. Okay, you should be seeing the Google form right now. So how to search for the power and sample size? Go to Google, type the word power, sample size, Vanderbilt. Power, sample size, Vanderbilt. Why? From Vanderbilt University. You click on this one, top one. You will see at the top, they give you a link to download. They got both versions, Windows, Macintosh, and Linux. Okay, just download the Windows version. It's only 2.5 megabyte, very small size. You run it and you'll get the software. Why is the software is very important? Okay, because it really helps you to calculate the sample size. I'm not sure whether I can open this thing or not. Let's see whether I can open or not. Okay. Software with you on. Okay, let's see whether, let's hope I can share. Okay, okay. I'm going to show you how easy it is using this software. So that in fact, after you see this software in action, you will realize that no need to disturb Dr. Azmi. Okay, no need to disturb Dr. Azmi. Why? Because you can just use the software and calculate your sample size. And not only that, it also will help to type your thesis for you. So you can see here, this is dichotomous. What do you want to know? I want to do a sample size. Is it mesh or independent? It is independent. Okay. Case control is prospective. Case control study is for looking retrospective. Okay, we have two proportion here. So the two proportion, what test we're going to use? We're going to use chi-square. Alpha is always 0.05. Power is always 80%. 0.8. Okay. The proportion of the disease among the non-exposed, 0.07 just now, we mentioned just now, the diabetes among the thin people. The rate of diabetes among obese people is 0.2%, 20%. What's the ratio? We wanted 1:1 for every one obese people. We have one normal size people, ratio 1:1. You press the word calculate, automatically they tell you the sample size required is 107. 107. So since you need 2 groups, so you can 107 times 2, you end up with 214. The best part, they even type what correct. You just have to copy and paste. So Ctrl C, copy, then you paste it to your PowerPoint. Okay, so no need to disturb Dr. Azmi. You can calculate the sample size your own. Not only that, they even write your thesis for you. Apologies, the throat is a bit dry. Okay, so that is my gift to you. PS2, power and sample size. Okay, I'm going to stop sharing now. Okay, let's go back to the lecture proper. Okay, so we are now back to lecture proper. So that software will help you a lot. So right now I am looking for the PowerPoint. I have no idea where the PowerPoint. Okay, there's the PowerPoint. Oops, aku dah keluar. Am I in or am I out? Ada? Okay. Sorry. The Zoom said I'm out, but the guy said I'm still in. So I'm going to proceed the lecture. So you already saw how easy it is for you all. Cantik. No need to do anything. You just copy and paste. So you can see here, this is a, wow, supposed to be 38. How come I got now? I got 107. Okay, never mind. I must have pressed the wrong button, you know. Okay, don't worry. You can try it yourself. Okay, you know lah, these old people getting excited, end up pressing all the wrong buttons. Okay, I just try again, dichotomous. Okay, dichotomous, sample size, independent, perspective, to proportion, uncreated chi-square, alpha 0.05. Oh, sorry, power 80% correct. 0.8. Uh, 0.07, 7%, 0.2. The ratio is 1. Calculate. Still 107. Okay, never mind. We figure out later. Okay. Okay. Don't worry. Okay. All right. So I'm back to the PowerPoint. Okay. Next. Okay. How about if the outcome is continuous data? How about if the outcome is continuous data? If the outcome is continuous data, then you can still use PS2 or you can use the Excel file. Okay, so you can, don't worry, either one can be used. The formula is given, the reference is given. Okay, for example, you are giving perindopril versus bisoprolol. How come I know that drug very well? I have to take it every day. Perindopril in the morning, bisoprolol at night. Bisoprolol punya nickname apa? Ubat jellyfish. You eat that one, you become like a jellyfish. Why? Because the BP drops, your pulse rate drop, and you cannot do anything. Useless. Sebab boleh tidur je. So let's say you have these two drugs you want to compare, and there's a difference of BP of 10 millimeter hydrogen, and you do study, there's a standard deviation of 20 milligram per 20 millimeter per hydrogen. So you want to calculate, you want to compare between two different groups, and these two different groups, this is the formula, Stanico and Cochrane 1989. Please take note, this one, the 2C, sorry, the 2C. The 2C. Somehow my cursor become kecil, I don't know why. Okay. So again, there's 2C. The 2C is different formula than the 2 plus C. Okay, so this one is for two groups. So you can see here when we do the formula, we put into the formula, you get a sample size of 64 per treatment group. So if you got two treatment group, you end up with 128. Okay, there's an Excel file there. You can use the Excel file. You can see also the Excel file will give you the same answer, 64 per arm. And or you can use PS2, and PS2 will also give you the same answer, which is 64 per arm. And the best part, they even give you the text. You just copy and paste. You just copy and paste. Master of copy and paste. Okay, when you copy and paste, it becomes like this. So please change the words with the items in red so that they become logical to the person reading. Okay, put in the word millimeter hydrogen, put in the word placebo if you're doing a study like this, or whichever study that you're doing, so that it makes sense to the person reading your thesis. If it is pre and post, before and after, the formula is slightly different. Formula is slightly different. Instead of 1 plus 2C, it becomes 2 plus C. Okay, it becomes 2 plus C. So your sample size becomes only a quarter, 1/4 daripada comparison. So you can see here, with this formula like this, instead of requiring 128 sample size, you end up requiring only 33. You end up requiring only 33. Okay, and the answer is same like in PS2. And okay, and I will end the lecture with these two URL. I know I give you all a lot of URL. I hope you're writing this somewhere, but anyhow, it is also inside the website. Okay, you want appointment to see statistician to calculate sample size? ppukm.setmore.com. This one will enable you to access any of the JKM lecturers. Any of JKM lecturers, you just go to ppukm.setmore.com. You select the lecturer and set the appointment. So, but please do it early, because right now the line is up to 3 months long. Okay, so you set the appointment. If you want help fast, I do it through the Facebook, through a group discussion. Okay, just go to fb.com/groups/ppukm research. Go there, join it, then post your questions, and I will do my best to answer. Okay, and with that, thank you very much. Back to the chairperson. I will stop sharing now. Stop sharing. Stop sharing. Oops. Sorry, cannot find my cursor.
All right. Thank you so much to Associate Professor Azmi. Is it possible for you to take question and answer? All right. So we have
so much.
Okay, so one question here in the Q&A box. Right. Let's see. So the first one is, how about animal study? I think this one is pertaining to your survey just now. Oh.
Okay, animal study. Okay, the formula is different for animal studies. Okay, but inside that slide of 114 slide, you go to PubMed.rt, the formula is there. The formula is there. There are about 8 slides on animal studies there. Okay, so just go to the website I mentioned now, PubMed.rt/sample size. The formula is there for animal studies. There are 3 different formulas that I give you inside there. Okay, for the animal studies. Okay, you can use any of the 3 formulas. Okay, That's for the animal studies. Okay, next one.
Right, next one, good morning. Why there are more than one formula? Any difference among them and how to choose?
Okay, first and foremost, the keyword that you have to understand, sample size calculation is just an estimate. Sample size calculation is just an estimate. So as you saw at the start of the presentation, I started showing you, even if though there is a difference of 50% response rate, okay, you need a sample size of at least 32 before the p-value become significant. So that is why we have to calculate sample size. But the sample size differs by the type of analysis. I have some more slides online on you go to youtube.com/drtamel. You see that there's a lot of slides I explain. For t-test, why the formula is like this. For chi-square, why the formula is like this. So basically, the sample size that is calculated, yeah, is based on the formula itself. Every one of these tests got their own formula. And for the p-value to become 0.05 or less, you must follow this formula to get the sample size. So that's why you have more than one formula. One, because one, it is just an estimate. Two, there are different types of analysis you use. So if you use continuous data, then you analyze based on formula for continuous data. You're doing it for categorical data, then you analyze, you calculate sample size using the categorical data. If you just want to find, you just want to do a prevalence study, and then you use a formula for prevalence study. Even formula for prevalence study, there are two popular formula. I give you the basic one, the original one, which is Kish L, 1965. But people don't realize, but Kish L got two formulas. There's one for unlimited population, which is they set the population at 250,000. And the other formula is for limited population. Okay, but I just showed you the one for unlimited population. If you have a limited population, Google for Craig-C and Morgan. Google for the word Craig-C, Krejcie, and Morgan. Then you get the sample size for the limited sample size, the limited population. Okay. Online start calculator. Go ahead and use the other online start calculator. In fact, that is the best. Because maybe your supervisor knows that better. But you have to understand, but some department, they are quite particular about the formula itself. Example, in psychiatry, they are a bit OCD and tons of apologies to psychiatrists. They want to see the formula. So that's why I showed you the formula. You just print screen, put it inside your thesis, and you'll be okay. So if you look at the notes that I gave you, inside the notes, every one of them got all the references for the formulas. Each one of the formulas got a different reference. Okay, so then you can go there. There's anonymous attendee asked, is there to go for basic stats? Okay, good news for you. It is also on Open Learning. Okay, but the URL is a bit different. tinyurl.com/fk6163 stats, STATS. Okay, just go there. Everything is there, including the video, the notes, the handout. Okay. Oh, sorry. Okay, this is another anonymous attendee asking about. He got so many tests. Okay, my dear, if you want to calculate the based on all these tests, you die. Why? Because you end up realizing that the sample size required may be very, very, very large. So usually in JKM, what we do, we go by the objective. You look at each of the objectives that you want to study, calculate the sample size based on the objective. And then you take the largest one. And then you take the largest one. So software, PS2. Okay. For PS2, there are t-tests, regression. T-test is for continuous data. Regression, if you're doing regression. So basically, it's back to your knowledge of statistics. Okay, but today I just show you only two. One is dichotomous for categorical data, and the other is t-test for continuous data. All the other formulas are covered inside the notes. Aha. Central limit theorem. Okay, this is a very, very old concept. Okay. Who came up with this central limit theorem? Okay, the person who came up with this was a friend of Carl Pearson. Okay, he's a guy who discovered your fingerprints. Forgot his name, but it's inside my notes lah. Inside my notes. And this guy believes that everything will regress to the mean. This guy, everything will regress to the mean. So if you have a large enough sample, then the sample size, then the normal, the sample will end up with following the normal distribution. But that one has got nothing to do with sample size. Okay, that one is so I did not cover about central limit theorem here, but inside my class in the basic statistics, we cover about central limit theorem. We cover about normal distribution. You can go to the URL I gave earlier, tinyurl.com/fk6163 stats. You can go and check it out. Okay, so everything is covered there. How it is formula are built on? It is from the statistical test. If you look back at the statistical test, each one of the statistical, they got the n there. And the n is the sample size. I wish I have more time. Then we can have a good time showing you the basis of all this formula. They started with the statistical test for the t-test. Who came up with the t-test? William Sealy Gossett. It's not a silly person, okay? Although the name is Sealy, it's S-E-A-L-Y, not S-I-L-L-Y. Okay, so William Sealy Gossett, he came up with that formula. Okay, so based on that formula, they reverse the formula, and instead of calculating the t, we are now calculating the n, and that is how this quasi-experimental study. Quasi-experimental study times 4. Sorry. What do I mean by times 4? Okay. You're doing a cohort study, or you're doing a clinical trial which is properly randomized, you can take the sample size as it is. But the minute it is become a quasi-experimental, then we have to do what we call the sampling effect. So the sampling effect, it could be times 2, it could be times 4, it could be times 3. You can check it out. But if I'm not mistaken, for quasi-experimental, it is times 4. Whatever the sample size you get, you have to times 4. Die. In vitro, you can check the notes, very covered there. Sorry, Hafiz. In vitro, okay. All this in vitro, all this stem cell genetic is covered inside that slides of 114. Okay. The website for Hayati, it is not a website. You can just download my notes, the full set of notes. The full set of notes, as mentioned just now, it is at palmx.org/sample size. Saya copy paste sekarang. Okay, so you just go and get it. Okay, pilot study. Okay, pilot study. Personally, on my part, the term pilot study, you have to be very careful. Okay, you have. I know this is covered by Fardania. I was there listening to the whole thing. Okay, so we have the pre-test. Pre-test means you just testing the questionnaire. You can just get 8 of your friends to sit down and go through your questionnaire. But you need to find 8 friends who are very, very obnoxious, very, very vocal, and like to talk and like to complain. So they will really complain about your questionnaire. That is pre-test. But when you talk about pilot, you are testing for the validity of the, or you are trying to find the trend before you do a real study. Okay, so personally on my part, you are doing a pilot study to validate a questionnaire, you need around 30 to 45. I rather err on the larger part, which is 45. If you ask me the last time when I was giving this lecture, I take 54. Why 54? Because there's And when we were running analysis, there's a term 27% inside there. So I end up setting the number of 54. But I just later I realized it's not really that important. So anything between 30 to 45, you are okay for a pilot study for questionnaire validation. But if you're trying to find a trend, when you do a pilot study, you're really doing a prevalence study. So the prevalence study, if you really don't know what is the trend like, you have to take 384. That's a magic number. All right. Okay. I think with that, it is already 10 o'clock. I think I have to continue next one. Am I right?
Yeah, but there's only one question, Prof, in the
Go
chat
ahead.
box, if you don't mind.
Okay.
So, hi, Prof, want to ask if my sample population is limited and I'm doing cross-sectional study, do I need sample size as well?
Okay. I know when you take all, by right, it is already everything that you can get lah. But I got good news for you. Under Craig and Morgan, okay, for example, if I'm doing a study in Klinik Kesihatan Rembau got only 32 staff. I want to do a study on stress in Klinik Kesihatan Rembau because I got only 32 sample size. If I use the Craig and Morgan formula, I will not need to take all 32. I can take only 28 out of 32. Okay, because of that. Okay, one you have to understand when you're doing the Craig and Morgan formula, they assume the prevalence at 50%. Why 50%? Because the prevalence of 50% will give you the largest sample size. Okay, so if you're still taking all, which is 32 of the Klinik Kesihatan Rembau instead of only 28 required, you're okay because you're taking more than that is required. So the whole point of you calculating the sample size is to prove to the ethical committee that you are okay, your sample size is okay. All right, but please take note, if you're just doing that, then your results can only be applied only to that place, only to the institution. You cannot apply it to the general population. Okay.
Right, I think that's about it. Right, so moving on to the next lecture.
Okay. Okay, so somehow I don't know what happened. Suddenly my screen become weird. The size become weird. I don't know why. Did I do something wrong? Okay. Somehow, sorry. My apologies. I must have pressed the wrong button and distorting my screen. Forgive this old man. Okay. Okay, next lecture is on explore, summarize, and present. Okay. Okay, I'm going to change my slide. My apologies. Tu yang tak ada break You're stuck with me the whole day. Okay. Okay, just take note. We are offering you assistant, personal assistant. Go to ppucan.setmore.com. Go and grab yourself a statistician. Okay. Ultimate offer. Very hard to get. Tawaran terhad. Okay, I see the problem now. Blackout. Okay, there's a blackout. So what happened? There's a blackout. My screen end up going to the wrong place. Okay, my apologies. Sabrina says she's going to have to watch this many times. Okay, my apologies. But don't worry, I have so many videos of this online. You just Google for my name. It is available everywhere, even on drtamil.me. Okay, I'm going to close this slide. I'm going to open a new slide. File open.